Guys, welcome back, and today we are going to do some more problems on current electricity. And the question is this: each of the resistors shown in the figure 32E1, this is the figure, has a resistance of 10 ohm, and each of the batteries has an EMF of 10 volts. Find the currents through the resistor A and B. So the resistor is 10 ohm and 10 ohm. Find each of the resistors shown in the figure 32E1, one has a resistance. So we need to find out the current through resistor A and B, because we're gonna draw the circuit, which is something like, let me adjust the camera a bit. So yeah, is it focusing? Yeah, okay. Now the question is, in fact the circuit is this. The way I'm seeing this question is that it has multiple methods to solve this question, but I'm gonna use KVL because it's the simplest. So ignoring this battery, I'm gonna discharge a current of magnitude I from this cell, and this and since a partition, or there are two different ways here, so the current will get split. Let it be I, and this one becomes the remaining current. So the I has to come here from here, so that it makes I here, because here I minus I. So by KVL's first law, it has to be I, the I current has to be coming from here, so that it makes a total of I in this circuit, so the current can move in this circuit. Okay, so this I, let it be I1, and let it be I minus I1. So how many unknowns? I, capital I mean small I, and I1. So the current through B is I, and the current through A is I minus I. So we need to find the values of I and I. So okay, we are writing KVL in this loop. Okay, this is loop 1, this is loop 2, this is loop 3. KVL in loop 1, which becomes, if we are going in clockwise sense, 10 volts minus I10 is equals to 0, which becomes 10 is equal to I minus I times 10, or 1 is equal to I minus I. Okay, now we're gonna apply KVL in let's say in loop 2. Okay, KVL in loop 2. Okay, so as you cannot see, but I'm gonna just simply move my camera here so that you guys can see. So this is the loop. Okay, look at it carefully. Now I'm gonna write KVL for that. Okay, I'm gonna starting in anti-clockwise sense or clockwise sense, it doesn't matter. So it becomes minus I10, 10 times I, okay, minus 10 I minus I1 plus I minus I times 10 is equal to 0. So 10 can be cancelled from here. I minus I plus I1 plus I minus I equals to 0. It becomes now minus 2I plus I minus 3I plus I1 plus I equals to 0. Okay, so this is the this is our equation number 1. This is equation number 2. Now KVL in loop 3. Okay, so I'm gonna write KVL in loop 3. Look at it carefully. Okay, is it clear? Yeah, it's focusing right now. Okay, now writing KVL in loop 3, which becomes 10 minus I minus I1 times 10 is equal to 0. So it becomes I minus I1 is equal to 1. Okay, so we have 3 unknowns and 3 variables. We need to find out the value of I, small I and capital I. Okay, so from 1 and 2, what we can write, I minus I. Okay, so we can replace capital I by 1 plus I. Okay, so minus 3I plus I1, or simply we're gonna replace I1 here. Okay, from 2 and 3. Okay, it will make our calculation much easier. So I can replace it by I minus I. So minus 3I plus I minus 1 plus I equals to 0. So it becomes minus 2I plus I is equals to 1. So this is the fourth equation. Okay, now plus negative negative, adding 1 and 4, 1 plus 4, 0, gone. 2I becomes, okay, whatever it gonna come, it come as I. Okay, so I comes as 0. Substituting this capital I, substituting this value of I in 1 in this equation, we can get I. So capital I comes out to be 1 amps. So the answer is, let me quickly check it. It's question number 35 subpart B. 1 ampere in A. Okay, 1 ampere in A. It's 1 as you can see, it's I, capital I minus I. So small I is 0, capital I is 1. So 1 minus 0, 1. Okay, 1 ampere, right? The answer is right. And 0 in B, and 0 in B, which is small I, and the value is, as you can see, it's question number 30. Which one is it? It's 35, 36. Sorry, 36. No, 36. No, 35. 35. Okay. So the answer, as you can see, 35 here it is. This. Okay. Got it? Yeah. So I'm gonna add more videos on this topic because it's one of the most interesting topics, I would say, because it's very easy and one can easily score good marks from this chapter. Now let's see some another problem. Okay, some other problems here, which is question number, let me quickly take it because we have did it, 34, which says, as you guys can read the question, figure this shows a part of an electric circuit. Okay, the potential at the points A, B, C are 30 volt, 12 volt and 2 volts respectively. Find the current through the 3 resistors. Okay, a very typical problem of Kirchhoff's first as well as second law. So this question is asked multiple times. You can see this question in any mock test paper and anywhere. So as you can see, A is at 30 volt. Okay, B is at 12 volts and C is at 2 volts. So this is the figure, something like this. Okay, it's 10 ohm, 20, 30. Okay, no problem. Now there are multiple ways to solve this. One is by assuming one junction to be at potential 0, so the current will flow from this to that, and then you can calculate everything. But I want to get into another approach. Let's say that the total incoming current is equal to total outgoing current. So this is at 30 volt. Okay, so let's suppose I current comes from here. It separates into two parts. Okay, I minus I. Let's suppose now writing Kirchhoff's law, 30 minus 10I, let it potential VV is equals to V. V minus 20I equals to 12. Okay, V minus I times 30 ohm is equals to 2. So we have three variables, which is I, capital I, V and small I, and we have three equations. This is first, this is second, this is so. And I have solved it through Kirchhoff's law, which is quite easy. I have assumed the potential here to be V volts. Okay, so the current flow from high potential to low potential. So this V has to be smaller than 30 volt. Okay, now I assumed current I flow from here. You can assume it from here, but I have assumed because from experience and from solving problems, it is better to assume current to be flown from a higher potential, from the most higher potential given in the circuit, in which in this case, which is 30 volts. Okay, so it's nothing new. You can take this here from here. So I, small I and I minus I, it breaks up, the current splits up. Now I have written Kirchhoff's law for all these three, from here to here, here to here, here to here. Okay, so yeah, this is the case scenario right now. So we're gonna solve it. Okay, so how we gonna solve it? Okay, that's the challenging part, because most of you face a lot of problems while solving it. So I'm making sure that I explain to you that how can you solve it. Try eliminating one parameter. Okay, for these three equations, try eliminating one parameter. For this case, I can eliminate V. Okay, I can eliminate V, which becomes, if I subtract, it becomes 30 minus 12, which is 2018, minus 10i minus 20i, which becomes 20i equals to 0. So it becomes 10i minus 20i equals to 18. Now similarly here, I can substitute V here by 12 minus 20i minus 30i plus 30i equals to 2. So it becomes 10i ti. Okay, it becomes 10i minus 30i equals to minus 10, which becomes 30i minus 10i equals to 10, which becomes 3i dividing by 10, minus I is equals to 1. So I got two equations. So I can write I as, small I as 3i minus 1. Okay, from here, as you can see, the value of small I is 3i minus 1. Okay, now I'm gonna substitute this value of small I in this equation. So what can I write? 10i minus 20, 3i minus 1 is equals to 18. So we can calculate I here. Minus 60i plus 20 is equals to 18, minus 50i is equals to minus 2, I is equals to 2 by 50, which becomes 1 by 25, which becomes 0.04 amps. So let me check. And the answer is right. Okay, so that's it for now, guys. Okay, I hope you enjoyed this session, and we'll come back. I'll come back with another video, and hope you guys enjoy that. I'm thinking of doing limits from maths. It's a very interesting chapter as well, and I don't know, give it a thumbs up, this video. And yeah, as you can see, I have pasted the structures of some popular inorganic acids, as you can see. If you want, you can copy it from here. I'm just showing you. Okay, and I would refer you to buy this book. Okay, this book for function and calculus. It's a very good book by McGraw-Hill Education, Vikas Rai. So it's a very good book. I think you should buy it, because it's a very good book, and it has multiple problems, and it covers all the calculus and function part. So yeah, that's it for now, and this book is HCV, as you have guessed right by now. This part 2 from current electricity. Okay, so that's it for now. Bye guys.